Hello, this is Zaza, and welcome back to another episode of the Organic Chem series. So I have the very nice step-by-step synthesis that I am already sharing with you. So I'll be covering the answers to this question. So I would recommend all of you to pause the video and try or try this question out. Honestly, in my opinion, I think this question is not too difficult. It but it's also not very easy because there's quite a bit going on, especially when you're looking at like a 8 step question. But yes, this question really tests you on what's covered in the organic chem reactions, like what legend says the 66 reactions. So I really think that this question is a good practice for you to like recall all those reactions. And yes, I would highly recommend you to really try it out before you review the answer, because that really trains yourself to like conquer this type of questions. But then again, in the actual papers, your step-by-step synthesis would probably not go more than 4. Like as in they would be considered generous if Cambridge gives you like 4 steps. It's quite unlikely that they'll give you 8 steps, because that means they have to give you 8 marks if you get it all correct. So this is more of like a practice rather than like an actual examination question. So without further ado, you can pause the video and try this out right now. Alright, so I guess you're done. And if you did not pause the video, in a nice way, I will say, I will assume that you don't know how to do this question, and the honors will be on me to go through this process with you. So let's begin. So we will start off by comparing, like my method to conquer these questions is to compare the initial the initial compound as well as the final compound. So what I like to do is to label the carbons. So let me go to the answer section. Okay, I kind of spoiled the first question by accident. But yes, what I like to do is I would test, I will I'll label the carbons. So you will label it as such: 1, 2, 3, 4, 5, 6. You should not be labeling the other way around like this. The numbers in circles, you are not supposed to do this. Reason being is because if you're going to name your compound, it's going to be like what 6 bromo something something something. But the rule of like naming these compounds is you want the smallest number possible. So you get like a 1 bromo 5 dimethyl hexane, if I'm not wrong. Yes, 1 bromo 4 dimethyl hexane. 5 dimethyl hexane, yeah. So that's how I would name it. And then if you compare the final, which is 1, 2, 3, 4, 5, 6. So you compare each carbon. So you notice that there isn't really much change with like, okay, I spoiled it. Never mind. Okay, you will notice that there is no change to 6, there's no change to 5. I think there's a change in 2 and 1. So 3 and 4, wait, no, sorry, there is no change to 5 and 6. Oh no. Okay, yeah. So no change to 5 and 6. And that means that you don't really have to look at 5 and 6. Don't you can just like ignore 5 and 6 for now, because there isn't really anything that you can do to it. You already have the structure in the initial structure and the final structure. So just focus on the first 4 carbons, alright? Alright. So yes, like I did earlier on, I kind of spoiled the first reaction. The first reaction is elimination. So you will eliminate because there is a hydrogen here, and you can eliminate this part. And then your first question might be, Zaza, why do you don't want to like do why must we do elimination? Okay, I'll explain to you. Cause there are many ways, like you can brainstorm on like what are the possible reactions that can happen. So elimination is one of them. You could convert your bromine to like your CN, your bromine to like OH, bromine to whatever you want. There's like possibilities. NH2, anything. But honestly, it's also more like working backwards as well. So if you compare the final product, what stands out to me the most is what stands out to me the most is that you will notice that you have these groups, the CH2 and H2. Why I say this stands out is because there is not a lot of reactions to derive this group. In if I recall it right now on the spot, there is only 2 ways. The first way is through RX. You get a CN, and then you can undergo a certain reaction to get this. Or the second clue is that you get like you have like a carbonyl group here, and then you undergo a certain reaction again to form your CN here as well as a OH. But I highly doubt that there's a OH here, because there isn't any OH. So I would steer clear of 2. It's just a prediction that I make, but then again I might be wrong, so we will not make assumptions right now. We will not make any like bold assumptions like, oh, number 1 is confirmed direction. It's just what we have in mind. Either you get your carbonyl, then you undergo that reaction to get this. Yeah, we just leave it over here. But if you really make me guess, I would go with number 1. It's just like it's a mixture of gut feeling and smart guess. Although I won't really call it smart, it's just something that I will lean towards to. Yes, okay, so enough of me bullshitting. I will just continue. So yes, elimination first. Then you get this. When after you eliminate that, it gives you a lot of possibilities. Because to me, elimination is more suitable because right now the aim is to go as close as to the structure possible. So what stands out is this, and this. We really figure out how we're going to do this, and I'll probably leave this towards the end. And also because there isn't really any way you can slot in like your CNs here, and then it's like you can't really, there's really no way you can slot it in. You can't free radical sub because you cannot guarantee that your halogens would free radical sub at specifically carbon 3 and carbon 4. So there is no way you can do that. But what you can do is you can eliminate and try to get this and try to get carbon 2 sorted out first. Because your carbon 1 is a bromine. Used to have a bromine, but now there's nothing here. But your carbon 2, oh wait, the 2 is missing. For carbon 2, it used to be a H, and then it becomes a OH. 1 and 2 that doesn't really seem to change that much, so I would just go with elimination. So I'll eliminate and I'll get this. So wrong. 1, 2, 3, and then 4, 5, 6. And then you'll notice that you can undergo electrophilic addition to get the OH and the H here. So it's addition of water, or it's just electrophilic addition. And aim for step-by-step synthesis is to get the major product. Very important. Major product. Which does fit this case because your OH will always attach to the carbon with lesser hydrogens on it. One has 2 hydrogens. And initially it has 2 hydrogens. And this does not have any hydrogens because there's already 4 covalent bonds to carbon 2. So you'll be adding 1 H and 1 OH here. So you will add your concentrated sulfuric acid cold, and then water and heat, and then you will get this. And then you'll be like, yes, you got 2. You got carbon 2 sorted out. And carbon 1 sorted out as well. Now you just need to add you just need to add something here. But the next question is, how are you going to do that? And that is where things get a little bit tricky. The people that I tested out tend to not know how to conquer this question. They don't really know what to do on this next step, which I have to agree it's not easy to go from here to the final product, because this is also the juncture where that opens multiple possibilities. So at this juncture, you would you will get an alkene again. And then the magic really happens because this is really where the synthesis this is where there's like multiple ways you can derive the synthesis of it. For now we would stick to getting a CC double bond first. So here, your CC double bond. Because there's a H here, and then you would CC double bond here. There's no reason why you should CC double bond here or here, like the ones in like blue, because that is essentially where you came from, and then now you're just undoing your efforts. Doesn't seem like it, right? So you would undergo an alkene. Then your question would be like, why do you even add this to begin with? I mean, then you'll be like, oh, I might as well just do something else. Why must I do what you say? Because the main point is because from where you got, right, your CH2 NH2, if I'm really going for my first assumption, then this carbon 4 can very well be used to it can used to be attached to a CN, but I'll write NC for now. And then it maybe came from an X, which could come from a double bond. So we're just working along this possibility first. And right now, it seems like it's possible, but we need to know how to get the carbon-carbon double bond here first. So what we want to do is to move towards our goal. You see, because you just saw how we got from the carbon double bond here to here. So we could work our way up. And yes, this is where I say the synthesis can branch out to multiple methods. So there are two methods. I'll go through the first method first. You could equals bromine this structure, and then you get bromine on one molecule, bromine on one carbon, and your hydroxyl in the other. So you get back that same structure, which is good. And you can undergo ethanolic KOH to get back your carbon-carbon double bond, which in this case, it will be your third and fourth carbon, something that you want, that you can go with assumption 1. This also confirms that you can use assumption 1. Your second method is to use the KMNO4 method, maltoxidation, so you can get your OH here and OH here. It works as well because from here you can also get your double bond. So once you undergo oxidation, you can undergo another elimination, and then you will get your carbon-carbon double bond on the third and fourth carbon. So here, your elimination will be at carbon 3 and carbon 4. Then from there, everything just flows in. Your bromine in CCl4, and the heat, and then you get this structure, and then you undergo your ethanolic KC and heat, and then everything just falls nicely into place. Undergo some reduction, and hey, you are exactly where you are supposed to be. So that's how I would derive this step-by-step synthesis. If you need the full answers, it's right here. And yes, that concludes my answers. So if you got any questions, you can drop it in the comments. I'll reply it as soon as possible. And yeah, I hope that you learned something from this, and I hope you have fun. Like I hope you can take away my thought process and apply it to like your other step-by-step synthesis. So really, one is to compare, and then you think of all possibilities. So you brainstorm all possibilities, and then just work your way out, because there's really no way that you can say that this assumption is truly correct until you tested it out yourself. So just go with compare, brainstorm, work your way out. That is what I would do, and it has served me really well. So I hope that you also benefit from this method. And yes, I thank you for watching, and if you want, you can subscribe. If you want, just give it a like, and I will see you in the next episode. Bye bye.